Hi everyone, we are Group 1. So I am the leader, Kai Jie. With me are Yongxiang, Jihang, and Yiting. So the project overview is to help rescue crews and retrieve the lost passengers. Hence, we are challenged to predict which passengers were transported by anomaly using records recovered from the lost spaceship's damaged computer system. So this is a photo of our team. And next, an overview of the data. We have personal records for about 2/3, about 8,700 of the passengers to be used as the training data. So we have categorical and numerical data, categorical are such as the home planet, cryosleep, and destination, while numerical data are such as age, room service, and spa. The detailed representation of the data are listed over in this slide. Next, we have two main objectives, which is first to use decision trees and random forests to make predictions, and after that, we will need to compare the performance of decision tree and random forest and pick the best out of it to make predictions about which passengers are transported. Next, let's go through a process of pre-processing. So firstly, we did feature reduction. So the cabin and name columns are dropped as their unique values, hence they do not help to generalize to the model. After that, we encode categorical data. So binary values such as true and false are mapped to 0 and 1. And our categorical data, which consists of home planet and destination, have each 3 categories which are encoded to 0, 1, and 2. After that, we handled the missing values by filling the missing values with the mode of each column. Then, we skewed the data using the Python standard skewer to prevent skewness of data and for clearer representation during the plotting of box plots. Last but not least, we removed the outliers after we plot the box plot to prevent skewness of results during training of the model. Next, Yongxiang will go through the decision tree model.
And a decision tree is a supervised machine learning model used for both classification and regression tasks. It represents decisions and their possible consequences in a tree-like structure. And in a decision tree, each internal node represents a feature of attribute. Each branch represents the outcome of a test on that feature, and each leaf node represents the final decision or prediction. The tree is constructed by recursively partitioning and the data based on the features that best separate or predict the target variable. So, in the decision tree code, I just use the adjusting the hyperparameter to get a better prediction. Yeah. So the first is define the parameter grid, and the second one is initialize the decision tree classifier. And next, to initialize a grid search CV. And next is train the decision tree model on the training data with hyperparameter tuning. And the next one is get the best hyperparameter. And the last one is to use the best model to make prediction. Next. And the next one is XGBoost. It means that extreme gradient boosting, and it's a powerful and efficient machine learning algorithm known for its speed and performance in various predictive modeling tasks. It belongs to the family of gradient boosting algorithm, which will be introduced in the next part, and which build a strong predictive model by combining the predictions of multiple weak models, typically decision tree. So for this one, first thing to do is to initialize the XGBoost classifier, and I use the same way to improve its prediction, which means use the grid search. So it's the same as the decision tree. So I define a parameter grid for the grid search and initialize it and train the XGBoost model with the hyperparameter tuning, and then get the best hyperparameter and use the best model to make prediction. Let's move on to the next method.
So the next part is AdaBoost, and here's my code. Here can break down to 4 parts. The first part is data splitting, and the second part is AdaBoost classifier, initialization, and training. And the next is prediction on the validation set. The next part is accuracy calculation and display. So what is the AdaBoost concept? The best principle can be summarized as follows. The first part is initial weights. Each sample in the training data set starts with the same weight to ensure equal consideration. The second part is iterative training. It means AdaBoost iteratively trains with learners, emphasizing previously misclassified sample by increasing their weights. The second part is weak learner training. Simple classifier like decision sums are trained on a weight data set in each iteration. The next is weight adjustment. Weak learner weights depend on their performance. Lower classification errors result in higher weights. The next is update sample weight. Weights of samples are adjusted based on a weak learner performance, boosting focus on the misclassified sample. The next is combining weak learners. The final model is a weight sum of all weak learners, with weights reflecting their training success. The last part is final model. AdaBoost produce a robust model effective in handling complex data sets while preventing overfishing. Yes, so the next part is 启航.
Okay, gradient boost is an example machine learning technique used for both classification and regression tasks. It's a powerful and widely used algorithm in the field of machine learning. Gradient boost builds a strong predictive model by combining the prediction of multiple weak models, typically decision trees, in a sequential manner. And there's several advantages that the gradient boost provide. And number one, it provides a high predicted accuracy. It often produces highly accurate models and is considered one of the state-of-the-art technique for predictive modeling. And the second is handling nonlinear relationships. Gradient boosting can capture complex nonlinear relationship in the data. And the last but not least is robust to outliers. The sequential nature of training allows gradient boosting to be robust to outliers in the data. Gradient boosting is a versatile and effective tool for various machine learning tasks, and is widely used in competitions and real-world applications due to its performance and flexibility. And on the screen, it shows the gradient boost code. And we first feed the data into training and testing sets and create and train a gradient boosting model. And we make prediction on the test set. Okay, let's move on the next page. Our conclusion among overload method boot, we find out that gradient boost had a better accuracy. Thank you.